Fiber optic assemblies, like these duplex cable assemblies, are used to transmit information at extremely high speeds in the form of photons, or particles of light. Litra Manufacturing, located in Norcross, Georgia, is dedicated to creating the highest quality fiber optic assemblies possible, and they've been doing so since 1995. It all starts with 300-pound reels of the highest quality Corning optical fiber being loaded into a cutting machine. This large fiber cable is threaded through the power drive cutter, controls are set, and it is ready to start. This machine measures and cuts the fiber assembly to the correct lengths and sends it down a conveyor to stations to be coiled. The longer lengths are laid out on the warehouse floor in a continuous S configuration. These 8-inch coilers can coil fiber assemblies up to 450 feet in length. After coiling, tie wraps are used to keep the coiled assemblies in round bundles. Next, they are moved into the fiber production room for further processing. The outer jacket is first marked and scored. Identification labels are printed and added to each end, allowing the assembly to be easily identified through the production process. Pulling on the ripcord will slice the outer jacket for easy removal. The central strength member is removed. Meanwhile, on the other side of fiber production, the smaller duplex fiber is cut to length and hand coiled. Connector boots and crimp rings are required during final assembly and must first be slid over the fiber insulation. The insulation is marked and removed, exposing the yellow Kevlar yarn. This yarn is trimmed to length and will add strength and flexibility when crimped to the connector. Each buffered fiber is precisely measured and marked, ensuring the final fiber length will be correct. The 900 micron buffer is now removed along with a protective coating exposing the bare glass. This is a very delicate process and extreme care must be taken. At this point, the exposed glass is fragile and can easily be broken. Next, epoxy is mixed and placed into a syringe. Each connector is filled with epoxy. The tip must be slid back and forth while adding epoxy to ensure the connector is completely filled. This special heat cure epoxy allows a long working time before the epoxy starts to harden. An oven protection sleeve is added to each connector. This ensures the exposed fiber is not broken when the next steps are completed. The connector is carefully slid onto the bare glass and the crimp ring is pushed up into place. After all connectors have been installed, it's off to the crimping station. Here, each connector crimp ring is air crimped to the manufacturer's specification. This process crimps the Kevlar yarn between the connector and the crimp ring, giving the finished assembly strength and durability. The shrink tube is heated and the connector boots are twisted into place on the connector. When all the connectors are crimped, they're off to the curing ovens. Here, the epoxy is cured for 15 minutes at 110 degrees and allowed to cool for 5 additional minutes before removing the oven protection sleeves. The excess fiber sticking out of the connector end face is now cleaved and easily removed. The end face is now hand polished to remove any excess epoxy. The fiber assemblies are now moved to the polishing stations. Each polishing plate will hold up to 40 connectors. Connectors are loaded onto the polishing plates for the polishing cycle. The industry standard is to run 3 polishing cycles for each batch, but Litra believes in creating the highest quality product possible, so they polish until all scratches on the end face are removed. This can take up to 2 additional cycles and ensures the lowest possible connector dB loss. During this process, each connector is inspected for scratches with a digital microscope. Connectors with scratches are returned for repolish and the process is repeated. When polishing is complete, each fiber connector is tested for dB loss. This is the measurement of loss of signal power at the point of connection. To ensure loss accuracy, dB loss is measured using a certified optical power meter with a stabilized light source. After each connector has passed the test for dB loss, the connector end face is again inspected, cleaned, and the protective cap installed. The smaller duplex assemblies are slid into bags, while the larger assemblies are wrapped. These finished fiber assemblies are now ready to be shipped. And that's how it's made.